Cancer remains one of the leading causes of death worldwide, largely because it is often diagnosed at advanced stages when treatment options are limited. Early detection significantly improves survival rates, but many cancers do not show symptoms until they have progressed. A groundbreaking discovery in medical science now allows doctors to detect cancer through a simple blood test, even before symptoms appear. This innovative approach, known as a liquid biopsy or multi-cancer early detection (MCED) test, analyzes biomarkers in the blood to identify cancerous changes at their earliest stages. In this comprehensive article, we will explore how the blood test works, types of biomarkers detected, benefits of early cancer detection, current limitations and challenges, future implications for cancer screening, ethical and psychological considerations. Conclusion: the future of cancer diagnosis. 1. How the blood test works. The latest blood tests for cancer detection rely on advanced genomic and proteomic technologies to identify traces of tumors in the bloodstream. These tests fall under the category of liquid biopsies, which detect circulating tumor DNA, ctDNA, fragments of DNA shed by cancer cells into the blood. Circulating tumor cells, CTCs, whole cancer cells that have broken away from the tumor. Proteins and metabolites, cancer-specific proteins or metabolic byproducts. Exosomes, tiny vesicles released by cancer cells containing genetic material. Key technologies used. Next-generation sequencing, NGS, analyzes DNA mutations associated with cancer. Polymerase chain reaction, PCR, amplifies small amounts of ctDNA for detection. Mass spectrometry identifies cancer-related protein patterns. Machine learning algorithms improves accuracy by recognizing patterns in large datasets. These tests can screen for multiple cancers simultaneously, making them far more efficient than traditional single cancer screenings, e.g., mammograms or colonoscopies. 2. Types of biomarkers detected. Different biomarkers provide unique insights into cancer presence. A. Circulating tumor DNA, ctDNA. When cancer cells die, they release mutated DNA into the bloodstream. Sequencing this DNA can reveal mutations linked to specific cancers, e.g., TP53, KRAS, EGFR. Used in tests like Gallery, by Grail, and Guardant 360. B. Circulating tumor cells, CTCs. Rare cells that break off from tumors and circulate in blood. Captured using microfluidic devices or antibody-based techniques. Helpful in monitoring metastatic cancers. C. Protein biomarkers. Certain cancers produce elevated levels of specific proteins, e.g., PSA for prostate cancer, CA125 for ovarian cancer. Newer tests combine multiple proteins for higher accuracy. D. Methylation patterns. Cancer cells exhibit abnormal DNA methylation, chemical tags that regulate genes. Tests like Gallery analyze methylation to predict tumor origin. 3. Benefits of early cancer detection. Detecting cancer before symptoms arise offers several advantages. A. Higher survival rates. Early-stage cancers, stage 1 or 2, have 5-year survival rates of 80 to 95% for many types. Late-stage cancers, stage 3 or 4, drop to 10 to 30%. B. Less invasive treatments. Small, localized tumors may only require surgery or targeted therapy instead of aggressive chemotherapy. C. Cost-effectiveness. Treating early-stage cancer is far cheaper than managing advanced disease. D. Population-wide screening potential. Unlike imaging tests, CT/MRI, blood tests are scalable for mass screening. 4. Current limitations and challenges. Despite their promise, these tests face hurdles. A. False positives and negatives. Some tests may miss early cancers, false negatives. Others may flag non-cancerous conditions, false positives, leading to unnecessary anxiety and invasive follow-ups. B. Identifying tumor location. While some tests predict cancer presence, pinpointing the exact organ remains a challenge. C. High costs. Current tests, e.g., Gallery, cost $900 to $1,000, limiting accessibility. D. Ethical concerns. Overdiagnosis of slow-growing cancers that may never cause harm. Psychological stress from positive results without clear next steps. 5. Future implications for cancer screening. The future of cancer detection may involve a. Integration with routine checkups. Annual blood tests could become standard, like cholesterol screenings. B. Personalized monitoring for high-risk groups. People with family history or genetic predispositions, e.g., BRCA mutations, could benefit from regular testing. C. A combination with AI and big data. Machine learning could improve accuracy by analyzing millions of patient samples. D. Development of new therapeutics. Early detection allows for novel immunotherapies and targeted drugs. 6. Ethical and psychological considerations. While early detection saves lives, it raises important questions. Should everyone be screened, or only high-risk individuals? How should doctors handle incidental findings, cancers that may never progress? What are the psychological impacts of knowing one has early-stage cancer? Balancing benefits with potential harms will require careful guidelines. 7. Conclusion: the future of cancer diagnosis. The ability to detect cancer through a simple blood test, before symptoms appear, represents a paradigm shift in oncology. While challenges remain, the potential to save millions of lives through early intervention is immense. As research advances, we can expect heavy checkmark more accurate and affordable tests. Heavy checkmark widespread adoption in healthcare systems. Heavy checkmark improved survival rates across cancer types. The dream of catching cancer at its earliest, most treatable stage is now becoming a reality, heralding a new era in preventive medicine.